A rough circular cylinder of radius 4a is fixed to a rough horizontal plane with its axis horizontal. A uniform rod AB of weight W and length 6a√3 rests with its lower end A on the plane and a point C of the rod against the cylinder. The vertical plane through the rod is perpendicular to the axis of the cylinder. The rod is inclined at 60 degrees to the horizontal. First job is some geometry. We have to show that AC equals 4a√3. So we add the centre point D. We draw in two radii, CD and DE. The radius we're told is 4a. We draw in the line AD, which will bisect the angle at A. So CAD is 30 degrees. This means that ADC will be 60 degrees, and we can do some trigonometry. We can say that AC over CD equals tan 60, which is √3, and therefore AC equals 4a√3 as required. We're told also that AB is 6a√3. The next part of the question is the mechanics. We're told the coefficient of friction between the rod and the cylinder is √3/3, and the coefficient of friction between the rod and the plane is mu, and that the friction is limiting at both A and C. So now we need to add the forces to the diagram. We start with the weight. It's a uniform rod, so we put the point G in the middle of AB. So AG will be 3a√3. And we have the weight W acting vertically through this point. At C, there's a normal reaction between the rod and the cylinder. This acts at 90 degrees to the tangent AB. So RC acts at right angles. The friction, FC, will be along the tangent in the direction CB. We draw a horizontal dotted line, and we can mark the angles. This will be 60 degrees, that's 90, and so this angle is 30. That will help us when we resolve our forces vertically and horizontally. And finally, on the ground, that's a rough ground, we have a reaction, RA, and a frictional force, FA, stopping the rod moving away from the cylinder. And as it's limiting, this FA will be μr. Resolving vertically, we can see the vertical forces upwards. There's RA, there's RC sine 30, and there's FC sine 60. And this will balance the weight, W. Substituting sine 30 equal to half and sine 60 equal to √3/2, we get another equation, which we can further simplify to give us RA plus RC equal to W. Resolving horizontally, the horizontal forces, the friction minus RC cos 30 plus FC cos 60 will balance to be 0. Changing FA for mu RA, putting cos 30 equal to √3/2 and cos 60 equal to half, and putting FC equal to √3/3, the coefficient of friction, times RC. We get this equation, which we can simplify to give mu RA equals 1/√3 times RC. Taking moments about A, we have the weight. The moment of the weight will be AG, which is 3a√3 times cos 60 times W, and that will equal 4a√3, which is the distance AC, times the reaction RC. We simplify this, we can see that RC equals 3/8 of W. We substitute this into the equation here, RA plus RC equals W, and it tells us that RA equals 5/8 W, and then using this equation we can calculate mu. Mu equals 1 over root 3 RC divided by RA, which equals 1 over root 3 times 3/5, which equals root 3 upon 5.